Yeah, welcome everybody. My name is Heiko. I'm probably invited because I'm one of the developers of the Ethereum project. Otherwise, when it comes to IoT, this will be a bit like PowerPoint karaoke. I guess I didn't prepare the slides for that. Question: who does not know what a blockchain is? Or who knows what a blockchain is?
If I don't have to explain it.
Okay.
Somewhere in between.
So because what I did not prepare is like a really introduction into blockchain technology. Because a lot of people in the community probably heard of this already, what a blockchain is in general terms. I can maybe explain how I think one could look at a blockchain if one compares it to databases as a short introduction. Then I would maybe introduce it to the Ethereum blockchain, which is a bit special compared to the first blockchain implementation, which was Bitcoin. And after that, maybe some words on how that fits in this IoT. And after that, my colleague will, yeah, we don't know what you're talking about. Bringing the economy into the Internet of Things. Actually, that's something I will also talk about. Yeah. Take your time. I think there won't be too much over. So then let's briefly look into what blockchains are actually good for. So, because I've been working with a lot of clients and they try to apply blockchain technology to almost any problem, and sometimes it's plain stupid because they would have better use just a MySQL database because they don't have the particular problems which blockchains solve. So there's also a question: what is new if you try to look at a blockchain stack as a database technology? So the one thing that is new, at least for an Ethereum-like blockchain, is that the authentication and authorization layer in usual application stacks is within the application, then you have like some user who writes directly to the database fields, right? And blockchain systems, you can have a system where this is checked very close to the point where data is written, and you can actually have data which you own as an external user. You can make sure that no one tampers with the data you've written there. So you can define rules who may update your data sets in that database, and if someone tampers with it, then you would notice immediately, and the system would not be in sync anymore. Everyone would notice. Basically, the one who is tampering with the system would not be in sync with the other ones anymore. So that's because we have something like a fingerprint. You probably maybe have heard of Merkle proofs and hashing functions. That's a way how we secure the integrity of the database. And if you combine these, you basically have the option to have a database which is run by multiple participants. There's no single administrator, there's no central server where the system runs, but you can really have multiple participants running a database together. Okay. So now a colleague from the Ethereum project had this code. Basically, if you have a SQL database and it's connected to the network and you replace it with a blockchain, something magical will happen to the good in some way. But I think it's not that easy. You should fulfill a certain list of requirements or your problem you're trying to solve. And that's the checklist we came up with. So it should be a shared database. We have multiple users trying to write in to the database. And you should have a problem with trust. So you would not trust anyone who participates in the system to update the database directly, but rather you don't trust them. So you could not decide who runs the database on his servers, who is the administrator who could tamper with the data. You would not agree on that. So blockchains are a technology for databases where you have multiple non-trusting writers. And usually if you have such a system, what you use is an intermediary. For example, in the financial industry, for financial industries applications, you have something like a bank in the center where you trust. So we're not having transactions between ourselves without having someone in the middle who we both trust. So, and if you have a problem where you have multiple writers, and you don't trust them, and you don't want to use you don't want to use an intermediary, then blockchain is really a good solution. The only thing that you need to make sure is that you can describe the logic which checks how to authorize people to write to the database, and this logic which can check the integrity of the database. If you can define this as code, then you can use blockchain technology for your problem. Are there any questions so far?
Yeah, question.
Yeah.
It's a bit stupid, but however, not just stupid questions. Like, I'm not a blockchain expert, and for me, like as a non-expert, the blockchain became at least popular in my regard in the bitcoins.
Yeah.
And I thought the blockchain is now some kind of hype, and the companies are trying it out, and the startups are trying it out, and from like encryption, like to bank and digital signature and stuff like that. And I wasn't aware that which are actually used like in a production environment. So is it already the case that there's actually banks or other companies that really use blockchain technology?
In production environments, not. Probably not. Okay. But they're looking into it, how to apply to real world problems they have. And actually although they are intermediaries themselves, they want to get rid of them. So they're in the process of moving money or settling transfers of securities. They have a lot of intermediaries which they have to pay for, and which slows down the process, and they would really like to save some cost there. That's for the financial industry, and they've been the first to look into that because they saw, hey, Bitcoin is something that we actually usually doing, transferring a value. How are they doing that? So that's my assumption at least. That's why they have been very early into looking into this technology. But there's a lot of other good use cases, for example, in supply chains, if you have some chains of custody, or in IoT, as we will see. Yeah.
Just want to make a short comment on that. In the financial industry, there are some early examples. For example, in the US, NASDAQ, the stock exchange, or the general exchange, they had a first trade executed via blockchain, which is kind of a milestone for them, but at the early stage there.
Yeah, they have a technology called Link or something, it's called, with LINQ, and I think it's pre-IPO, pre-public registering of who are the owners of the shares or of the stock options for not yet public companies. But I think they had like 5 companies participating, so that's more like a test, I think. So it's no real serious.
So I've got a question on the methodology. So you said that the deployment on the distributed network is open to everyone wanting to participate. So if you say you can define the business logic, who can write into the blockchain database, I call it, and how you can ensure that this business logic can't be changed on the local deployment?
I can, but actually then this node goes out of sync, because either you have like a 51% attack in this regard, that the 51% of the nodes update their business logic to evaluating, then you have like a majority. But if just one node updates their logic, for example, mines a new block, proposes a new block to the network will refuse the block if it's not according to the original protocol.
Okay, so every node checks the surroundings like in a routing network. So they look, okay, are you applying to our rules which you find in our network? And so if you don't, they say, okay, you're out of the system.
Kind of. Yes, basically they send messages like data blocks, and those data blocks need to conform to a certain protocol specification. And if they change that specification locally, the others will just reject it.
Okay.
Yeah. There's another remark you made about your idea that anyone could join the network easily. That's true for public chains, but there's also nowadays something called private chains, which are a bit different, where you can have like a whitelist of members. That's something that the industry uses mostly. Okay, so now I would tell you something about the blockchain technology called Ethereum. Who has heard about Ethereum already? There's someone who never heard of what Ethereum was. Okay. Yeah. So what is it? But you heard about Bitcoin. So Bitcoin is the famous blockchain technology where you can send bitcoins easily without having a central party. You can send bitcoins from A to B. And so in my view, Bitcoin is like one application built on top of a blockchain technology stack. It's a Bitcoin basically implements one possible use case on top of the blockchain technology. And people notice this when they try to have something like crowdfunding and arbitrary assets mapped on Bitcoin and use Bitcoin for these use cases, but this was kind of clumsy and hard to develop on top of Bitcoin, and therefore the idea of the Ethereum project was to have a platform to build decentralized blockchain-based applications. And the platform should make it way easier to build those applications. And yeah, actually this never worked out. It's not that easy, but it's way easier than it was in Bitcoin. So maybe a short introduction to what are distributed applications. So traditional applications have certain features which are different than for distributed applications. So usually they have a single point of failure. Even if you have a cluster of servers in multiple data centers, there is still an administrator who could censor the application, or government could enforce the provider to shut the application down. You would not know if someone updated the code or tampered with the databases, and so you basically have to trust them. So in basically all cloud services, you somehow have to trust them with the data, and that they're not manipulating it or deleting it at some point. If you have a distributed system, there's always a problem how you reach consensus. There's traditional algorithms in computer technology for that, like Byzantine fault tolerance algorithms. But in public blockchain technology, we have a new approach, which is economic consensus, basically. So if you are not playing by the rules, you basically lose money. You're losing money because then you would try to mine, which burns electricity, and you get no rewards. That's the short form. I don't want to get into mining because it's a big topic. So distributed application features are basically you have not to trust anyone, which is quite good. They are open source by nature because the code has to be seen by everyone who participates in the network. They are decentralized and autonomous in the sense that they cannot be shut down, and there's no central administrator who can step in to fix things or manipulate things. And the consensus reached by blockchain technology. Examples of distributed applications that we have seen is name registration. Think of DNS systems, for example, domain name server systems. Any token systems and currencies, that's like the Bitcoin token, like assets you could represent on a blockchain. We've seen decentralized exchanges, prediction markets. Because this is a good technology for financial applications, we've also seen financial derivatives. You can use it for escrow services. Basically, for example, a crowdfunding service, what's happening here, it's kind of an escrow. Everyone says, I want this company to receive my investment if we have a certain threshold reached. And so someone needs to take all the money in escrow. And if the threshold is reached, the startup gets the money, otherwise the investors get their money back. And therefore you need someone who takes that in escrow. That's something blockchain is really good for. Actually, I think identity and reputation systems is a really hard problem. There's no magic bullet, but blockchains can help here too, because they at least bring the public-private key infrastructure with them out of the box. Yeah.
Can I just ask, what do you mean by prediction markets?
Prediction markets are, it's like betting on the outcome of future events. So it's often used within companies to, for example, have the employees in the company bet, will this product be successful, or when will we be able to deliver this product, or it could be a betting market who will win the next elections, or who will become the next soccer champion, or questions? Okay, so now we could go a bit deeper into the Ethereum system, but I will try to make it short because otherwise you are lost in technology details. So again, the idea is that distributed applications are a bit hard. So what we've seen is, for example, there's a system called für DNS, wie heißt das? Namecoin? Namecoin? There's a system called Namecoin. So they wanted to use the Bitcoin system to, basically Bitcoin technology, to have domain name system, to build a decentralized domain name system based on it. And so they basically forked the Bitcoin project, forked it, and implemented some things a bit differently to have their domain name registration. And people have started doing that for many applications. The problem is each of them needed to bootstrap a new blockchain. And to bootstrap a blockchain, you have to have a certain set of miners which are working on it in order to have it secured. So that's the mining topic. So, but basically the problem is you have the bootstrapping problem. This is a bit hard. And therefore it's good if you have a platform where you can just deploy your dApp. There are a lot of dApps, distributed applications, and you just add your new dApp next to them. And that's what basically Ethereum tries to provide. So now we could walk through the technology, but I just wanted to talk maybe about smart contracts. This, for example, is the code example for a very easy domain name system on top of Ethereum. So it's just like 4 lines of code, 5, and it basically says, if the name is not taken, then register this name, which would be message data 0, for the sender. Yes, for the sender of the transaction, and otherwise do nothing. That's basically it. In real world, it's a bit longer, but shows you the power. That there's all things like a network which synchronizes which propagates messages in the network, like all the peer-to-peer layer, like transaction validation, like public key infrastructure, authentication, authorization. Most of this is cared for you already, and you only have to really write a tiny piece of code to get a pretty complex application. If you look at the DNS system and the code base, it's not an easy thing usually. Is anyone interested in the details how Ethereum works? Really? So what happens is you write your code, then you compile it to Ethereum script, which is bytecode which gets executed by the Ethereum virtual machine. This is a new virtual machine. Why is it a new virtual machine? Because we do something that's called gas counting, which is basically counting the cost of every operation. The alternative would be that you just like time out the code. For example, you don't want anyone to run the right code which just loops forever, because then the system doesn't converge to a new state. Therefore, you need somehow to manage that everyone agrees if a transaction was valid, if it did not consume too much resources, and then you need to know how much to charge for the transaction. And therefore, you really have to count the cost of every operation. And that includes how much memory was allocated, how much storage was used, how many operations did we execute. And in blockchain systems, everyone who participates validates all transactions. So this code needs, if there is a transaction goes in, every node needs to validate all the transactions, and they all have to come up with the same outcome of the transaction. It would be the results, which data is written, but also what are the transaction costs. And therefore, you cannot do that easily with a virtual machine out of the box. Therefore, we had to create our own virtual machine. Questions? Yes.
Is the code for the virtual machine public?
Yeah.
Public code.
Yeah. Okay, so we've been at compiling our code. So deploying code is basically sending a transaction to a special address, which is just a 0 address, and have the code in the data field. and this will create a new account, which in this case is what we call a smart contract, because the account has not only value, like 2000 Ether, and an address and a nonce, like in standard blockchain systems, but also some code and storage. And when you send a transaction to this contract, which has code, then the code is executed in the context of whatever is in the transaction. And for example, this transaction we send in data, we want to register a name. And after that, you see the storage gets updated. So we have a state transition based on the code being executed on the data from the transaction. And the code could also work on the old storage, on the old data which is in storage for that contract. And every contract has its own local storage. No other contract can tamper with that storage, except if the contract provides methods to do so, in which it would probably check if the other contract or external user is allowed to do that. Yeah?
All this data and the code, it's all saved in the blockchain?
Yes. Yeah. So that's the actual limitation. You should design your applications in a way that you don't have too much data in the blockchain, because that will increase your transaction cost.
Can I use the output from one contract as an input for the next contract, for example, chaining them?
Yes.
Okay.
Yep. Actually, it supports subcalls, so you can really see this as an ecosystem of multiple contracts which can work together to build larger applications. This is like a dummy scenario, but you could think about multiple sub-services in the blockchain working together to implement some application. Yeah.
I think there are 3 languages at least which are supported. Which one would you use, or
Would be
for I think the Serpent and Solidity and another one?
Yeah, there's certain Solidity. One was called Newton, one which was LLL, for Lisp-like language, something like this. So certainly Solidity or Serpent at the moment. I would say by now Solidity is a bit more mature. So that would be my preference. Yeah, and maybe not again comparison to Bitcoin. So we have basically there's scripts in Bitcoin, so you can have more complicated things, but basically we're trying to generalize state transitions from one state to the next state by having a Turing-complete virtual machine in between. So we talked about this already a bit. So there's for every operation in the virtual machine, we have a certain cost table, and we can calculate the cost of the transaction. And this is how an application actually would look like. You would have the network of nodes, and you would have your local nodes, which uses the PHP stack to connect to the other nodes. And in here would be basically the blockchain system, and the node provides a JSON API, which is accessed by an HTML JavaScript application which runs locally on your machine. Yeah. So distributed applications are like split in 2 components. One is JavaScript, or something that runs outside of the node, and one thing runs inside the virtual machine of your node. Okay, limitations are because every transaction needs to be validated on every node in the network. Basically, the whole system cannot be faster than the slowest node in the system, right? So you cannot have data-intensive or computing-intensive applications on top of that. Yeah, something that the industry is complaining about, everything is public. You can see all data in blockchain, nothing. They are funny guys. So first they praise the blockchain technology for adding transparency to the processes, and next they complain that there's no transaction privacy, right? It's one of the hard problems that many are looking into right now when it comes to industry applications. And of course, the blockchain system, it cannot actively look up external data. It cannot do fetch just URL source to put in data, but all data needs to be sent in by external transactions. Yeah.
We have a distributed network of applications, and how do I update or replace smart contract?
Mm-hmm. So usually smart contract cannot be updated. Once the code is deployed, the code at this address at least cannot be updated, and that's actually a property that you as an external user want, because you do not want to rely, or you want not to have to trust someone who has the key to update the code for some applications. For other applications, you might trust the developers, and then they can create like the outer layer of the application in a way that they use like something like a name registry to look up the address where the actual code nowadays lives, and then just forward the call to that contract. Right?
So it's a whole bunch of redirecting going on all the time, probably.
For example.
Okay.
Yeah. Yeah, there's still means how we can get in data feeds into the system. We were talking about external data, how we get it in the system. Basically, you have to game theoretic algorithm how you could make sure that external entities provide the correct data to systems. And this shelling scheme, they would deposit some value, and then they would all send in the current value of the data feed you're looking for. And if there are outliers, they would not get the deposit back, and if they are cooperative, they can earn some money. Yeah, so these are old slides. Last year we've not been live at that time, but now we're live since July. And we already have, I think, 6,000 nodes on the network, which is not too bad compared to, I think Bitcoin has 8,000 nodes. And so I think since a week or so, it's also the second most capitalized cryptocurrency blockchain system. It's more a blockchain system than a cryptocurrency. In Ethereum, the main part that we have cryptocurrency is only because we also use economic consensus, and therefore you have to have some means to incentivize consensus, and also we need like a currency to pay for the transaction fees. But there is actually no reason that this is its own currency. This could be any currency, and this is probably something we'll be doing for version 2.0.
Can I just ask you, what's the source for the last slide?
The source? Coinmarketcap.com.
What about Bitcoin Classic, Bitcoin XT, and that kind of stuff?
Yeah.
For the last, I can't find it.
For the last slide?
Yes. Is it all into the Bitcoin?
I think so, yeah. There's no forks yet.
Because Bitcoin Classic is a fork, and it's now the second one.
Well, it's a very new fork, is that right? From this discussion from the one developer we reported, is that right?
Yes.
So probably there are not too much nodes online.
They are doing it. David Anderson said that he's not doing it.
Okay.
So yet there is no fork.
But there's not going to be a fork.
There might be a
What
fork
he said.
someday, but not today. There is no fork yet. Bitcoin XT, what's the name of him again? Gavin Anderson. And he says he won't increase block size no matter what happens. And the rest of the network might someday increase block size. And at this point we will have a fork, but yet there is no fork.
Okay.
And no problem at all.
Thank you.
A big discussion.
Okay, now comes the PowerPoint karaoke part.
Sorry, can I ask one more question?
Yeah.
Can you talk a little bit more about these transaction fees? Because if I get it right, the user, or you pay for trust of the system, right? So you pay for the integrity of data,
Yeah.
and who gets the money in the end? All the participants, or
No, that's just like the Bitcoin system. The one who proposed the last block, which made it into the chain of blocks.
do you also have to mine these blocks in Ethereum?
Yeah.
In the same way as Bitcoin does it?
Basically, yes. Yeah.
Okay.
So how it works is everyone sends in their transactions to the blockchain system, and then why do we have mining at all? Because we need into this open system where anyone can participate. We need to agree on the one who brings the transactions in a certain order. Because everyone would receive the transactions at a different point in time, and everyone would have a different order of transactions, and they would not reach consensus, which would be a hard problem. And therefore, that was the innovation actually from Bitcoin, or one of them, is that you decide on the order of transactions by selecting one guy who solved this mining puzzle that's first. And so he can propose the order of transactions, and he gets the reward for that block, and also he gets all the transaction fees for all the transactions which have been in that block, and then just like in Bitcoin, basically. Yeah.
Sorry?
Yeah.
There was some discussion going on about proof of stake versus proof of work in Ethereum. Is there a new...
It's decided we will have proof of stake probably by the end of the year or early next year, and we're currently working on this. And the algorithm is called Casper. C. Yeah, we're currently working on simulations and hopefully soon on a test network.
So this will be a new network then?
No, we will upgrade our current network. So much about decentralization. It's just if now the developers decide, if the code developers decide we will upgrade the network, probably everyone will follow. But actually, it's not very decentralized, right? Yeah. Okay. Okay. So I'm not very experienced with the Internet of Things topic, but what I learned is that there are some problems with it. Actually, there's a report by IBM from earlier last year, I think, where they mentioned some problems and basically recommended that blockchain technology could be a good fit for IoT, because the alternatives is to have like centralized infrastructure, which they thought is not good, very good fit for the opportunities ahead. So you probably know this. Ethereum blockchain is one big open API. You can figure this maybe by thinking about how these services can cooperate on the blockchain. So with this slide, I think the idea was to say that what are the alternatives? How can we organize registration, data management for IoT systems? Obviously, we could have the big companies running big servers. We could have open cloud services with open APIs, or we could have like really decentralized, distributed services to interface, or which the IoT devices use to interface. Yeah, I think this is basically what the democracy of devices, that's what IBM said. That's what they're aiming for if they apply blockchain technology to IoT problems. And they're still working on this actually, bringing this forward using Ethereum as the system. Anyone else in the room who can explain better how that could be a good fit? Okay, we'll come to some use cases. Maybe then things become more obvious. So my colleague made an example with the next Airbnb. How could that look like? So basically, imagine, I think Airbnb might be a not so good use case because it's actually private rooms, but say that would be hostel rooms or something like this. Then here's the problem, the lock, right? You need to coordinate how do you get the keys, how do you get in, and how do you, when are you allowed to access the store? And so this lock could be a smart property device. The smart property device would synchronize with the blockchain, and well, in advertising outside of the blockchain, people would inform each other that this door opens if you send a certain amount to a certain address, like this one, in the blockchain. And if you're a user and you want to rent this room, you basically send with your smartphone a certain amount to the address of this smart lock, and then it would open. You probably would have some synchronization that it can map your device when it's close to the lock of the door. And if you move out, you maybe would get back your deposit, but then the door would not open again. Right? And so the smart lock actually, you're talking about smart property, actually the whole apartment could be smart, so it could notice that someone moved out and it needs to inform someone to clean up the room, and could even pay the person who cleaned up the room, and could also pay anyone who needs to do some maintenance tasks. So that's the future perspective. I think the example works better with cars, because cars are like autonomous robots. They can drive to, in the future, they will be able to drive to the car dealer themselves and get an update or whatever. Another use case is if you talk about energy. You know, there's consumers and producers, and there's also prosumers. That is someone who has a PV system on their roof or has a wind turbine. So they're also producing energy. Usually, if that's households, they usually consume as much energy as they produce, but at some days they might have too much energy. And then they would try to sell energy, and ideally they would sell energy to their neighbors in the neighborhood, so that you don't have to use the capacity of the wires to move the electricity too far. So, but how can they buy the electricity? Today we have big exchanges, energy exchanges, but I think that the smallest size is like 10 megawatt, what they're trading. And in this system, you could basically, a consumer who wants to have some energy could, with blockchain technology, use a decentralized exchange to bid for the next kilowatt hour. Just really tiny steps, and then pay per kilowatt hour. But this would involve many transactions, because this granularity could be even smaller, like just 1 minute of 1 watt second or something. It's thinkable. And these are really tiny amounts. And if you had all these transactions in blockchain, then everyone who validates the blockchain needs to replay all these transactions on the blockchain. And therefore, we're working on technology which is called the RAIN network. And the RAIN network is a bit different than a stock blockchain. It uses a blockchain, but only as a mean to dispute conflicts. So in the main blockchain, every participant would put some value in escrow, like a deposit. And then basically all transactions would be off-chain, just bilateral. Only those participants who are involved in the transaction, they would basically sign an updated balance between each other, like the netted updated balance. And they would do that for years and be happy all the time, except if they don't agree at some point. That could be if one of the participants goes away and you cannot trade with them anymore. And then you had the option to settle the balance on the blockchain, because your counterparty put something in escrow. And the broader term here is micropayment channels. You might have heard of this. But the RAID network, which is comparable to the Bitcoin Lightning Network, can leverage multiple channels to connect participants who have no direct connection. So we can have transfers between any two nodes in such a network, even if they don't have a direct payment channel. Yeah, that's the technology we're currently developing in our company, and this really helps to scale out asset transfer capacity. So usually, if you look at blockchain systems, they do at most, I would say, if they're run over the internet, at most something like 500,000 transactions. We have seen 10,000 transactions in the lab, but in real-world systems, I doubt that they will ever do more than 500 transactions anytime soon. So you see, they're not scaling, not really scaling. And for example, as a comparison, Visa payments, they have, I think, like 40,000 transactions peak per second. So blockchain systems currently are not a solution for that. Yeah? Okay. But you know, we're 5 billion people. If they all just buy breakfast, this will not go on a blockchain currently. But it would be something we could handle with something like the RAIN network. Yeah. So both claims here. The cost of transfers are really, really low. So it's like a really tiny fraction of a cent, and we could basically scalability is unlimited unless you have a lot of settlement and channel openings and closings on the blockchain. But otherwise, the transfers which are off-chain, they scale perfectly with the number of participants.
Is this similar to the Ripple network a little bit, or is it?
Yeah, it has similar use cases, but the technology stack is different. Okay. Something else it adds is basically transaction privacy, because those transactions, most of the transactions don't go to the shared ledger, but only are between the participants who are involved in transactions, so no one else can learn what you're buying over the day. And yeah, another important thing is asset transfers are instant. So I don't know if you know that about blockchain systems, but you have to wait a certain number of blocks. Like there is a recommendation to wait 5 or 6 blocks. That would be 1 hour for Bitcoin systems and like 1 minute or 2 minutes for an Ethereum system. In RAIN network, because there's something on the screen on the blockchain. Once you got a signed message saying the updated balance is X, you can be sure that you will at some point in the future be able to claim that money on the blockchain. So you can immediately offer the service or whatever you want to purchase. So one use case could be Spotify, for example. Currently, you have one big transaction per month, 10 euros per month. In the future, you might have like 10 million transactions per month, all a fraction of a second, because you're paying for every second of music you're listening to. This kind of models is something that you could implement based on that technology too. So that was my part on IoT. Questions? Yeah.
I have one question. In Europe, is there any, let's say, so-called like startup companies? They are selling their shares by buying blockchain technology. Is there any companies or related technology startups are doing this? So selling their shares by blockchain technology.
KNC, mining firm. So there is a company in Sweden. They're producing Bitcoin miners, and they are selling on a local. So it's not like Nasdaq or something like that. It's a local stock exchange, and they're selling on those local stock exchange parts of their company, and they are somehow connected to the Bitcoin ecosystem. So it's not you're not buying part of the company, but you're buying a part of well, it's backed by Bitcoin,
Okay.
kind of. But it's hard to get from here. You got to be somewhere in Sweden, and I'm not an expert on that field, but something like this exists.
Because I thought this smart property ideas is actually suitable for the shares. But I do not know what is there any companies available in Europe? Because in China there are 2 companies already doing this, selling startup shares by distributing blockchain technology.
Which companies?
One company which is one of my friends is called Small Ant. It's a very tiny company located in Shanghai.
Well, the problem I think is that it's not regulated. So
Yes.
if you want to sell shares in Europe, probably also in China, it's a heavily regulated market. So you can offer your shares on the blockchain. That's not difficult, but
It's not recognized by the law.
it's not regulated. So
Yes. Maybe they are also in the tryout step. They are not doing it in a large scale.
And in Europe, it would be illegal to sell shares without a regulator in between, or a CSD or anything else.
Are you sure? Even for very small batches.
They would have to apply the regulations. If they apply the regulations say that you have to have some intermediary. If it's a bank that does the IPO process or a CSD that issues the asset.
Okay. So I always think that actually crowdfunding on the blockchain would be very nice if you could have equity crowdfunding, not get it like a T-shirt or a coffee cup for your crowdfunding sponsorship, but really shares in the company. And the cool thing about blockchains would be that they could handle the complete process of the crowdfunding, then the issuance, trading of the shares in the company, and even corporate actions like paying dividends or having votings in the company. So that's something that you could really model on blockchain stack. That would be very cost efficient.
but also crowdfunding is regulated. So
Yeah.
I mean, in the end, you have to pay taxes on the shares, at least, and the state will be interested in this to get the taxes. So you need to authenticate yourself to the blockchain, I guess, somehow. And that's the problem that you have to have up to now a central counterpart here of some choice. How would you otherwise do that? I mean, how could you ensure that taxes get paid? Because that's what regulators are basically interested in.
Well, if we're talking just about blockchains, it could also be like private or consortium blockchains. So it could be, for example, blockchain run by multiple non-colluding parties, and they could enforce your customer process. And the blockchain could be a way that only whitelisted users are on the blockchain.
So then it's not that much decentralized, but it's a centralized system using blockchain technology.
Yeah.
And I guess that's what we will see in the future.
Okay, but that might be a good discussion topic for the break. Again, thank you very much, Heiko, for stepping in.
Thank you very much. I see some familiar faces. We are there in September. We are progressing with our software, and with our ledger, I'm going to present a private ledger. So that's something different as what we heard before. Now Ethereum and, for example, the Bitcoin blockchain ledger. Everyone can participate. We developed a private ledger where, in fact, everyone can participate, and but not everyone is equal, and not everyone can run nodes. But I will get back to that later. A few words about the company. We say we are a European company. We live in the European continent, and headquarters is in the Netherlands. We have also people working in Ireland and in Spain. Myself, I live in Germany. And we focus on development of blockchain technology-based solutions. We develop end products. We're not core developers, and we have already a number of applications in operations. We have a B2C digital currency exchange, Happy Coins, where you can buy bitcoins for euros and exchange bitcoins for euros. We have a B2B settlement platform completely run via APIs, where business clients can sell or buy bitcoins without holding themselves bitcoins, and so they don't have any volatility risks, and they don't need to know anything about the bitcoins themselves. Furthermore, we applied the patent. I didn't tell that much about it in September. I will get back to that on my last slide. But in fact, it's a payment over an insecure connection, and so we are speaking about internet connected devices, and there will be 50 billion by 2020. But there are many more devices that are not connected to the internet, and somehow you might want to pay them as well. So you want maybe to pay a light bill in the future. So how are you going to pay these devices? So the basic problem that blockchain solves is we are moving from an internet of information exchange to the internet of value exchange. I think that's the basic difference. If I send a mail or download music, watch a video, all the time it's copying. If I send you a mail, I still hold a copy. Yeah, so it's duplication. But that works fine with mails and pictures and videos and music, but not with money. So if I send you money via the internet, like I do with an email, it won't work out. So what we do with blockchain, it's an exchange of assets, and that's basically it. You agree? So without copying, we can exchange assets. And a number of problems you can solve with blockchain and the Internet of Things. Probably this list is not complete, but I think it's might be the biggest problems. Security, data security, ownership, who owns a device, settlement, and smart contracts. And the last two things is what we are working on at Quantos. So, what happens? Why we are a fintech company? But what brings us to the Internet of Things? Well, first of all, we see that worldwide the number of transactions is growing exponentially, and mainly because we are getting more devices that we can pay to, and these devices can maybe pay them other devices. At least we see the number of transactions increases. And furthermore, smart contracts appear. Why? So we see new payments flows evolve with new needs, micropayments, P2P payments, and you get new needs. And the banks, why are banks interested in blockchain? You might always want to know what your competitor does, but it could also help them to enter this market, the market with the new payments. They cannot enter this new payment market with the existing infrastructure they have, and the blockchain might help them there. So what we basically delivered so far is an infrastructure for digital cash payment. So it's a whole new infrastructure, and the most important part of that infrastructure is a connector between a traditional bank account and a digital cash wallet. So how do you get your money from your traditional bank account on your mobile wallet? Not with SoFort or with PayDirect, but real digital money on your smartphone. And this digital wallet can be used by enterprises, consumers, unbanked consumers, appliances, so the Internet of Things, and it makes P2P payments worldwide with instant settlement possible. So that's basically what we develop with Quasar. And these wallets will simplify the settlement for the Internet of Things. So some of you might already know this slide. And not come up with a better one, and nearly everyone understands it, but I will use it maybe 4 or 5 times and then I throw it away. But this is Joost, and the other one is me, and Joost is my old mentor. I know Joost for more than 30 years already, and we call once a month about bigger and smaller problems. And one time I told Joost, there's a small part of my keyboard broke, and you have a 3D printer, and that must be fantastic. Can I design a new piece for my keyboard? And he said, well, not a problem. Download Google SketchUp. This is the 4th or 5th version, but I managed to produce something, and I sent a data file to the 3D printer from Joost. Now Joost lives 650 kilometers from my home, yeah? But I could send the data file to the printer, and it printed a spare part, and Joost sent it to me, and the big question is, how am I going to pay Joost? Yeah? It was 18 cents production costs, and if I make a payment from Germany to the Netherlands, it would cost more than €1, so doesn't work out. Yeah. So and then well, if I can send data to this printer, why can't I pay the printer? Yeah. So when I'm sending the data, I also make the payment. And then, you know, when a printer is running out of materials, also laser and 3D printers, it starts blinking, and you get all kinds of messages on your screen. So the printer knows he's running out of material. Well, if the printer knows it, why should Joost order the material? Why shouldn't the printer order the material directly? And if the printer holds money, it collects with printing spare parts for me, it could pay also the material. And this is the problem, what we solve with Quasar. We make payments between people and machines and other machines possible. And you see we have blue and red wallets, and there's a reason for that. So I told you we have a Bitcoin exchange, Happy Coins, and one of the biggest problems we've had with this digital money was the KYC and the AML. Yeah, so where do the Bitcoins come from? People come to this exchange with Bitcoins, we don't know them, we don't know where the money comes from. It's the whole KYC AML procedure. Well, a machine can do KYC. Yeah? A machine doesn't have a bank account, but somehow you want to make these machines, internet-connected devices, become part of the economy. So we created, we call it red wallets. And these red wallets you can download from the internet. I will give you the website where you can download a red wallet immediately. So these are red wallets without any permission. And then we have the so-called blue wallets. And blue wallets are connected to a traditional bank account. And if you want digital money on your blue wallet, you make a small transaction from your bank account to your digital wallet and back. And finally, the banks, they get their money from the central banks. Well, this is a system that's not available in Bitcoin or in Ethereum. So what you do have, you have an issuing authority, and you have real exclamation marks money. So what you see here, the money in the red wallets comes from the blue wallets, comes from the euros at the end, as we have them on our bank accounts. So you can do a transaction from a blue wallet to another blue wallet, from a blue wallet to a red wallet, from a red wallet to a blue wallet, from a red wallet to another red wallet, but you never can do a transaction from a red wallet to a green wallet. So, and that solves the AML problem. Yeah, so if you want to, if Joost wants to monetize the money his 3D printer makes, he has to transfer the money from a red wallet to his blue wallet and then to his green wallet. How can this help the Internet of Things? So today, I think Internet of Things devices is mainly a business of recording and relaying sensory data. Yeah? But tomorrow we are going to get much more complex business models. So what we will see that agents empower devices to autonomously trigger actions based on information they receive. So they are going to act themselves. And they can execute complex business rules, and that will increase productivity and reduce intervention. So we get this network production, and the IoT, I think, is the layer for network production. So these data and devices are able to connect freely, mix, and create new services and businesses. But how are we going to pay? And whom are we going to pay? Yeah? So we don't, I think it makes no sense to streamline the business, to virtualize business, to the leanest production we've ever had, and then have a financial monster. Yeah? So all these small transactions with machines and businesses, other machines don't know. So and also there, these red and blue wallets can be of help. Yeah? They can be the basis of a new reconciliation ecosystem. So a device, a red wallet or a red wallet, becomes its own profit center. And you could build, we discussed it already, you can build your organization structure with wallets. Yes, you can make a projection from your organization structure on these wallets. And there are an infinite number of wallets. Yeah, 7 times the cent that we have on Earth is about the number of addresses we have for wallets available. And if you want to run a financial performance analysis on your enterprise, you just have a look on the blockchain ledger, because the blockchain ledger is always accurate. There cannot be mistakes on this ledger, and it's instant. So you don't need your bookkeeping systems as they are now. But last but not least, you can also do automatic real-time clearing and settlement, because these wallets, red and blue wallets, they can run with smart contracts with agents, and they can act as autonomous agents. So these smart contracts, you already told about it. I will tell you my words. So what smart contracts are self-executing agreements that verify whether conditions are met, securely hold value, and automatically release payment. And there's no need for a middleman. And that are the 3 basic things. So if these wallets operate with smart contracts, they can really do this automatic settlement. You just want to know if conditions are met. Yeah? Did Joost printer produce my spare part? I think the big challenge is this proof of performance. Yeah, data feed that will prove performance. Have conditions been met? And there we have oracles that are online service providers broadcasting data which can be used as input. So we worked with some of these oracles, but you're moving, or it's a moving problem. Yeah. So we had a middleman in the past. If I want to sell my shares, I could call the bank and say, so how much does SAP shares cost now, and for how much can I sell them. Well, I can have an Oracle, have the Reuters website and look for the SAP share. But somehow this can be compromised. So it's, I would say, the Oracle problem has not been solved yet. Yeah, so there are some experiments with distributed oracles, 7 or 9 or 100 servers, providing information, but it's not been solved yet. And the idea of a smart contract is not new. It's more than 20 years old. But until the blockchain, yeah, there was a lack of a financial system to support programmable transactions. So smart contracts have been there for a long time, but only the blockchain makes it possible to transfer assets secure. And that will end up, we can end up with very complex business models. So decisions based on more accurate or recent information that we collect from devices. We can achieve personalization and differentiation. So we can target every smart contract for every single person, for every single transaction. Yeah? And that will lead to flexible pricing models, depending if it's non-recurrent transactions, long or short-term clients, or service levels we agree upon. And the nice thing is about these smart contracts is that you can look them up. You can look them up in the blockchain. Yeah. As I said, so the rules in the smart contracts are executed on the blockchain, and everyone can see the contract. Yeah. We are working now on a project. Smart contracts are most of the time very simple. Yeah, it's just if then else rules, and it's the reinventing of the cash on delivery and advance payments problem. So it does not have much to do with IoT, but it's a smart contract. So you have the problem. The purchaser doesn't trust the vendor that the vendor delivers, and the vendor doesn't trust the purchaser that he pays. So we have the cash on delivery or the advance payments. Yeah? So, but it costs a lot of money, yeah? And one of the two parties is not happy. So, and here we can have this blue and red wallets in place. So if the purchaser orders a bicycle, yeah, and the vendor receives the order, a red wallet can be created. So yeah, we can create wallets all the time, and this wallet is what we call an escrow wallet. So only limited access, and the purchaser makes the payment to the red wallet. So the vendor can immediately see that the money has been paid. Yeah? I think it's about 30% of all the cash on delivery deliveries go back to the vendor because the purchaser doesn't have the money at home. Yeah? And nowadays it's quite hard. If you order something for 900 euros, you have to go to the bank, and in many cases you cannot get 900 euros out of your ATM because you can only have 500 a day as a maximum. So you don't want to go 2 times to a bank to get 900 money. So if you would do that with a blue wallet, you put the money in the red wallet, and it's there. So the vendor sends the bicycle, and when it receives at the purchaser's address, you could say, well, the purchaser, I didn't receive the bicycle, and the money remains on the red wallet, which doesn't make sense because it won't be sent back. But there we have the delivery service, which acts as a digital notary. Yeah? And you know they have perfect tracking and tracing systems. So the only thing they have to do is when they receive the signature that the goods have been delivered, send a signal to the red wallet. In fact, they have a key, and the money will be transferred to the vendor. Right? So you can say if the goods are not delivered before 27th of February, it's a part of the smart contract. Yeah? We deliver the goods within 2 weeks. Claims the vendor, if the goods have not been delivered within 2 weeks, the money automatically is sent back to the blue wallet of the purchaser. So it's an example of a, I think, very simple smart contract, but you can disrupt the whole internet payment. All the so forths, direct pays, credit cards, you don't use them anymore, you don't need them anymore. And especially vendors pay 3%, 2%, have to wait 2 to 3 weeks before they get their money. They have the chargebacks from PayPal users. There are no chargebacks with wallets. So wallets are very useful, can really change. As I said at the beginning, you can do settlement and data security in blockchain. I don't think it's you must use it for it, but you can use it for it, and it's more or less the same as with the delivery. So A buys data from sensor B, and this will be a micropayment. A pays an amount into a multi-signature escrow wallet. C, as we had it with the deliveries. B sends data to A and sends a data hash code to C. So I generate, or the sensor generates a hash code for the data it sends to A, and A receives data and checks or sends also a hash code to C. So if the hash code matches, it means the data have not been changed during or in transit, right? So it's a data security. And if equal, send money from escrow wallet C to B, and if not, it didn't receive the data, or the data has been corrupted, can send it again. But that's basically a part of a smart contract for IoT data transfer. A few words about our system architecture. It's based on Stellar, but it's a private ledger. We think that in our system, or the nodes are operated by banks. There is a role for banks. Banks somehow generate trust still. We still trust banks. If you have 100,000 euros, you can give it to Google or to Apple or to the Commerzbank or your local Sparkasse. We probably all say when we go to the Sparkasse or Commerzbank and not to Google or Apple. So we still trust banks. They can operate the network. They operate the nodes. And they have the green and white wallets, and a small API to the blue wallet. To transfer money from your bank account to a blue wallet and back. And basically that's it. It's quite a small system. But it has a lot of possibilities. So how far are we with the system? We have a private ledger running, not on 6,000 nodes, a few less, but it runs. You can download different wallet types from Quasar Ledger, and we are working on APIs. And they will be published, I think, end of March. And that means that everyone can start programming. Everyone can run red wallets on machines, because a wallet does not physically have to be on the machine it's where a payment is made to. So, as I said, you can download the wallet from quantusledger.com, and if you open it, it's either a blue. No, it's not a blue. It's a it's a red wallet. Yeah? But you can send a request to connect it to your bank account. Just try it out. Yeah, I would say. Yeah. Download it, send a mail, and you go to the procedure, connect it to your bank account. And we've done that with our Bitcoin exchange more than 15,000 times. So we know that it works. Yeah? With the euro, it's still we have a huge disclaimer. So they are not real euros. It runs as a test. We're not going to pay you real euros. We're not going to charge your bank account. But you can try the blue and red wallets. So as I said before, we have a lot of internet-connected devices in 2020, but we will have many more not connected devices, like a vending machine. And you want to make a payment with your blue wallet or your red wallet to this vending machine. So we developed a protocol that enables secure payments to non-connected devices over an insecure connection. So I have my smartphone, and this smartphone makes a connection to the vending machine with Bluetooth, and I have a payment server, and this payment server has a lot of red wallets, and one of these red wallets belongs to that vending machine. So I make a payment from the red wallet from my smartphone to the red wallet on the payment server that's connected to the vending machine, and the vending machine will send a hash via my telephone to the vending machine, and it will pop out the Mars or Bounty I bought. Okay, so this is a transaction between two red wallets, where the red wallet is not on the machine itself. Yeah, so you don't need to have a red wallet on the machine itself. It can be anywhere. And in this case, it's even a red wallet from a machine that's not connected to the internet.